Hi there. We are on day 5 of Unit 2, and these are properties of parallel lines. So in the warm-up, they're asking us to find the measures of each labeled angle and give a reason for your solution. So in the very first picture, hopefully you guys are getting used to seeing that line. And with two angles on a line next to each other, also called a linear pair, they will add up to equal 180. So you can also call them supplementary. So if we take 180 degrees and we take away the one side, which is 145, that will leave us with the angle on the other side, which ends up being 35 degrees. And so we can say that A is equal to 35 degrees. And a reason for our calculation, we could say a linear pair equals 180 degrees. So the 145 and the 35 add up to 180. Okay, in the next picture, we have that crossing, those two crossing lines that intersect, and they form 4 angles. And remember, the one that they give us is 40. The easiest one to get is its vertical angle will also equal 40 degrees. And so we can say vertical angles are congruent. To get the other two angles, you're going to have to think about the first picture that we drew. There's that straight line again. And if we think from C and B, there's that half circle. And so those are also a linear pair. And so if we take 180 degrees and we take away the 40, we'll be left with 140. And so at B here is 140 degrees. And if you think about it, D is its vertical angle, which would also be 140 degrees. Or you can look at this straight line here, and you can look at the half circle here. There's lots of ways to come up with it. So we use vertical angles are congruent to get the 240s, and we used a linear pair again, just like we did in the first picture. Linear pair equals 180 degrees. Okay, so those are our reasons for our solution. In the very last picture, this looks like angles around a point. We're looking for this angle that goes from there to there, and then we have the 122. And so together they form 360 degrees. So if we take 360 and we take away the 122, we will be left with 238 degrees, which is what E equals. Okay. And we can call our reason for our solution angles around a point equal 360 degrees. And there's a couple other ways that you could have done that. You could have said that this part of E is 180, and that this part here, the 122, and this angle here, this would have had to be 58. So the 122 and the 58 add up to 180. And then you could have done 180 plus 58 is also another way of getting that in a 238 number. Okay, so a couple different ways with angles. All right, so coming down, we're talking about parallel lines today. Parallel lines are coplanar lines that have no points in common. Think of like railroad tracks. They run alongside each other and they will never meet. Or you could also say that they have all points in common. So if you draw a line and you draw another line right on top of it, those lines are actually technically considered parallel. They have all points in common. So no points in common or all points in common. We're going to focus this year on no points in common and our parallel lines looking like that. We got to talk about a transversal, which is a line that intersects two lines. And our transversals will most likely always cut two parallel lines. Okay? And when two parallel lines are cut by a transversal, there are 8 angles formed. Okay. And you're going to see that in all of these pictures coming down here. Okay. Sorry for my child screaming in the background if you hear him. That's Cameron. He's 3. So here are our parallel lines. And here's the transversal that they labeled with a capital T. And notice there's 1, 2, 3, 4, 5, 6, 7, 8 angles that are formed. Not all of them have different measures. In fact, 4 of them have one measure and the other 4 have another measure. So this first one we're talking about is corresponding angles. And that's going to be a tough one for you guys with vocab. Angles that are in the same position. They correspond to each other. For instance, John's seat in 7th period corresponds to Marissa's seat in 7th period. They sit in the same spot, just in a different period. So with corresponding angles, they're in the same or similar location, just on a different parallel line. So if I take a look at, let's go with angle 1. Angle 1 corresponds to angle 5. They're in the same position. So if you think of angle 1 being in the upper left-hand corner in this intersection up here, okay, angle 5 is also in the upper left-hand corner in the intersection down below. And that's why angle 1 and angle 5 correspond to each other. Okay, so we also have to figure out what their relationship is. I like to do a highlighting thing. You can do whichever you like. What I like to do is I like to highlight angle 1 in one color. Angle 4 is going to be and have the same measure because those are vertical angles and vertical angles are congruent. And if I keep that same highlighting pattern, I would highlight 5 and I would highlight 8. Okay, if I highlight the other 4 angles, 2 and 3 would have the same measure because they're vertical angles. And then if I drop that intersection down, 2 would fall on 6. So 6 and 2 have the same measurements. And 7, therefore, would be the same measure as 6. All right, so the 4 red angles are all equal to each other, and the 4 green angles are all equal to each other. And if you notice, 1 and 5 are the same color, and therefore 1 and 5 would be congruent because they are the same measure. All right, so another pair of corresponding angles would be angle 2 and angle 6. They correspond to each other. They're in similar locations, just on a different intersection of the transversal there, different parallel line. And they're the same color, so they would be congruent. Angle 3 would correspond and be congruent to angle 7. And angle 4 is congruent and would correspond to angle 8. And so corresponding angles are congruent. Okay. All right. So our next angle pair name is alternate interior angles. And again, I'm going to do the same thing with my highlighter. I'm going to go ahead and highlight 1, highlight 4. They're vertical angles. They would be congruent. If I drop that intersection down, 1 would fall on 8 and 1 would fall on 5, 4 would fall on 8. Okay. And therefore, once you got those 4 done, the other ones, you just fill those in with the other color. Okay. So when they talk about alternate interior angles, they're talking about the interior angles. Interior is in between your parallel lines here. Okay. So there are these 4 angles on the interior of the parallel lines. And when they refer to the word alternate, they mean on alternate sides or opposite sides at opposite ends. So if I go ahead and pick angle 3, its alternate interior angle would be angle 6. So 3 is on the left-hand side. Alternate refers to on the other side, which would be 4, but at the other end, which would be 6. Because remember, they still have to be on the interior of the parallel lines. And if you notice, 3 and 6 have the same color. Therefore, 3 and 6 would be congruent. Okay. If I pick angle 5, it's alternate interior angle. So alternate referring to the other side, which would be where 6, but the other end, which would be 4. Angle 5 and angle 4 are alternate interior angles, and they're the same color. They're both highlighted in red, and so they would be congruent. All right. So they are our angles on opposite Sides of the transversal, but also between the two parallel lines. Alternate interior angles are congruent. Okay. All right. So the next one up is very similar, except it's alternate exterior angles. So I'm going to go ahead and do my highlighting again, and I totally suggest doing it. I think it helps. You just have to make sure that you have a highlighter with you. Okay. And I would have two colors, although you don't, once one color is done, I guess you don't need the second color. Okay. But makes your picture nice and pretty. And we're looking for alternate exterior. So we have to remember what exterior means. These angles up here are on the outside of your parallel lines, and these angles down here are also on the outsides of your parallel lines. And so those 1, 2, 7, and 8 are referring to exterior angles. Okay. And again, with alternate, so let's say I pick angle 1. His alternate exterior would be on the other side of the transversal, but also at the other end. And so you would end up with angle 8. Okay. Notice angle 1 and 8 are both highlighted in red, and so that makes them congruent. Angle 2, his alternate exterior, so if you're at 2, go on the other side of the transversal, you would be at 1, but go at the other end, you would be at 7. So angle 2 and angle 7 are alternate exterior, and notice that they're both highlighted in green, and so they are the same color, so they are the same measure, and therefore they are congruent. Okay, so alternate exterior angles are angles on opposite sides of the transversal, but outside the two parallel lines. Okay. Alternate exterior angles are congruent. And so these are the three main ones that we focus on because they give us congruent angles. But there are two more pairs that don't give us congruent angles, and they are called, I like to call them same-siders. Okay, so the first one up are same side interior angles. Before I go, I'm going to go ahead and do my highlighting. So there's 1 and 4, 5 and 8, okay, 2 and 3, 6 and 7. And because they're talking about interior, we're going to go back to the 4 angles inside the parallel lines. Okay. But this time they're calling them same side interior. So if I pick angle 3, his same side of the transversal, same side interior would be 5. But look at 3 is green and 5 is red. Therefore, they're not the same color. So they are not the same measure. What we do know is that they are actually going to add up to equal 180 degrees. Okay. Angle 4 is also an interior angle. And if I'm looking for his same side of the transversal, that would be angle 6. And again, take a look. One's red, one's green. So they're not the same measure. Therefore, they're going to add up to equal 180 degrees. Okay. So they are a pair of angles inside the parallel lines and on the same side of the transversal. Same side interior angles are supplementary. Did you ever hear of an alliteration? It's an English term. Alliteration is one of those things where you have like a sentence where it all begins with the same sound. So I always remember same side supplementary. Hopefully that helps you. Okay. We have another pair. These ones are called same side exterior angles. So again, I'm going to go back to do my highlighting. 1 and 4 have the same measure as 5 and 8. Okay. 2 and 3 have the same measure as 6 and 7. Okay. So again, because they're referring to exterior, we have to make sure that we're looking at the angles on the outsides of the parallel lines, which would be 1, 2, 7, and 8. Okay. Because they say same side exterior, if I pick angle 1, his same side of the transversal exterior would be angle 7. But take a look, 1 is red and 7 is green, so they're not the same color, so they won't be the same measure. Instead, they're going to be supplementary. They're going to add up to equal 180 degrees. And likewise, angle 2 and angle 8 are same side exterior angles, and they will also add up to equal 180 degrees. Okay, so there are a pair of angles outside the parallel lines and on the same side of the transversal. Same side exterior angles are supplementary. There's that alliteration again. Okay, same side supplementary. Okay, so in summary, when two parallel lines are cut by a transversal, any pair of angles will either be congruent if they're corresponding, alternate interior or alternate exterior, or they will be supplementary. Those are the same side interior and the same side exterior. All right. All right. So let's go ahead and see if we can do the couple questions on the back. And I will see you guys in the next video.